Alright, Unit 3 is rationals. So if it says simplify a rational, what you need to do is factor the numerator. So if I factor the numerator, it's going to be y minus 6 over y plus 3. And I factor the denominator, 2y and y. Let's see. I want plus 1 plus 3. There we go. So now that I got the numerator and denominator factored, I can see if anything cancels. And nothing cancels. I don't have the same binomial in the numerator and denominator, so I can't cancel anything. That's done. It is simplified, so that's kind of a silly question. Let's try another one. Rationalize the denominator. You're not allowed to have radicals in the denominator, so you need to multiply by the conjugate. So the same two terms, but you flip the sign. Radical 2 minus radical 7. In the numerator, I'm going to distribute 2 radical 2 minus 2 radical 7. And in the denominator, when you FOIL this, you're going to get radical 2 times radical 2, which is 2, minus radical 14 plus radical 14. Those cancel out. And then radical 7 times negative radical 7 is negative 7. So I have 2 radical 2 minus 2 radical 7 over 2 minus 7 is negative 5. I got no more square roots in the denominator, so that's my answer. You can do the same thing by rationalizing the numerator. I'm just going to multiply by the conjugate in the numerator, and then the same thing in the denominator. And when you do that, in the numerator, like I said before, you're going to FOIL this and get radical x times radical x, which is x. Radical x times x plus h is just going to be positive and negative. Those cancel out. But when you multiply negative radical x plus h times positive radical x plus h, you just get x plus h. But that's a quantity, so you got to make sure you put parentheses there. In the denominator, I have 4 radical x plus 4 radical x plus h. And when you distribute the negative, the x's are going to cancel out, and you'll have negative h over 4 radical x plus 4 radical x plus h, and that's your answer. So simplifying the numerator, sometimes that's a handier thing to have than simplifying the denominator. You guys will see that when you get to calc. Simplify the rational. So this is division, so I need to factor all 4 parts of this fraction. So the numerator, when I factor, is going to look like that. Let's see, plus 1, plus 1. There's top left. Bottom left will be x plus 5, x minus 3. Now I need to flip this, so change it to multiplication. Copy, change. Now this is going to be in the top. And when you factor that, it's 2x, let's see, minus 3, minus 1. There you go. And in the denominator, this is in the denominator because I flipped it. X plus 5, x plus 1. So let's see if anything goes away this time. That goes away. That goes away. All right. And now I got in the numerator, so 2x plus 1, 2x minus 1 over x plus 5 quantity squared. Now you might need to expand this like this. You could write this as 4x squared minus 1. If it's a multiple choice test, you just got to be prepared to see multiple forms of the same answer. So you might have to expand the numerator. You might even have to expand the denominator, but we'll just stop here and say one of these is probably the answer. Simplify. So when you have a fraction, usually your best bet is to, when you have to get a common denominator, usually it's good to see what each denominator is made up of. So I like to factor them. They don't have anything in common. Well, they have an x in common, I suppose. So this guy needs another x, and then he'll be x squared. This guy needs an x plus 1. So now I have in the numerator x plus 1 plus x over, they have the same denominator, it's x squared, x plus 1. So I have 2x plus 1 over x squared, x plus 1, and that's probably fine. You might distribute in the denominator, but it doesn't really matter. Simplify compound fraction. So let's focus on the numerator here. This is going to be c minus 1 over c minus 1. That's 1 plus 1 over c minus 1. This is just the numerator of the fraction. So I'll draw this big fraction bar and focus on that. Now I'll do the same thing with the denominator. C minus 1. Let's try that again. C minus 1 over c minus 1 minus 1 over c minus 1. So I'll simplify this a little bit and say, okay, what's this equal? This is c minus 1 plus 1 over c minus 1. And then in the denominator, I have c minus 1 minus 1 over c minus 1. This is all going to be in the numerator. Let's see, those cancel out. So c over c minus 1. And then I still have this middle fraction bar just to kind of keep things nice. C minus 2, come on. C minus 2 over c minus 1. Now I can copy, change, flip. So I copy the numerator, c over c minus 1. Change this division to multiplication and flip the denominator. And when you do that, these quantities are going to cancel out, and you're just left with c over c minus 2. So that's a lot of work, but none of the steps are particularly difficult. Let's keep going. Solve the equation. You need to get a common denominator. I like to get a common denominator for all the terms. You don't have to do that, but I think it makes it a little bit easier. So I'm going to give this guy an x plus 9 in the top and bottom. This guy's going to need an x in the top and bottom, and this guy's going to need both x plus 9 over x plus 9. So that now that everything is over the same denominator, I can basically say, look, if I multiply both sides by x plus 9, the denominators all go away, and I just have the numerators to deal with. So 10x plus 90 plus 98x equals 9x squared plus 81x. If you get the same denominator for all parts of the problem, then you can ignore the denominator. And now I just got to solve this quadratic. So 9x squared, I need to move this 108x over. So if I move 81 minus 108x, I'm going to get negative 27x, and then I got to subtract 90. So I'm just solving this quadratic by getting everything to one side. Now I can factor x squared minus 3x minus 10. Please be factorable. Yeah, that's factorable. X minus 5, x plus 2. So x either equals 5 or x equals negative 2. Or does it? You got to go back and check and make sure you don't have extraneous solutions. Does 5 work? Yes. Does negative 2 work? Good. So I have two solutions, 5 and negative 2. But sometimes you have extraneous solutions, so just be careful. Let's do another one like that. This one, though, you don't really need to get a common denominator. You just need to cross multiply. So 8 times x plus 2 equals 5 times 4x minus 2. So this is pretty straightforward. You just got to get everything on one side. So there's going to be 12x equals 26, which is 26 over 12. Those are both even, so 13 over 6. X equals 13 over 6. If you want a decimal, that's fine. You can keep it exact. You're going to have a repeating decimal. X-intercepts, y-intercept, asymptotes. So I need to find the x-intercept. There's potentially more than one. I need to find the y-intercept. There's only one y-intercept. And I need to find the asymptote. So I'll probably have a vertical and horizontal asymptote. To find the x-intercepts, you set the numerator equal to 0. So I'm going to set the numerator equal to 0, 2x squared. Actually, you know what? I can probably just factor it right now. 2x squared plus 5x minus 6. So 2 multiplies to negative 6 and adds to 5. 6 and negative 1. Yeah. So x is negative 6 and positive 1. Those are my x-intercepts. I like to write those as ordered pairs, negative 6, 0, and 1, 0. So first I have my x-intercepts. To find the y-intercepts, you plug in 0. So you just get negative 12 divided by negative 6, which is 2. So I got the x-intercepts, I got the y-intercepts. Now I got to find the asymptotes. So vertical asymptotes are when the denominator is 0. So to find the vertical asymptotes, I set x squared plus x minus 6, which when you factor, there are going to be vertical asymptotes at x equals negative 3 and x equals positive 2. So I have two of them. And horizontal asymptotes, to find the horizontal asymptotes, you got to look at the terms, the degree. So if they have the same degree, that's nice. They're both quadratics. I just divide the coefficients. So 2 divided by 1, I'm going to have a horizontal asymptote at y equals 2. Depending on the degree, you're going to have to do something different for the asymptotes. So if they're the same, you just divide them. Now we're going to do the same thing. So I'll first find the x-intercepts. So x-intercepts are when the numerator equals 0. So that's at negative 2 and 1, 2, 3, 4. So first thing I do is find the x-intercepts. Now I got to find the y-intercepts. So I plug in 0. I can't plug in 0 because there's an asymptote. And that I'll just draw it right now. There's a vertical asymptote along the y-axis because you cannot divide by 0. And then the last thing, I need to find the horizontal asymptote. Well, there isn't a horizontal asymptote because the degree of the numerator is 2 and the degree of the denominator is 1. I need to do long division to find the slant asymptote, x squared minus 2x minus 8. So you got to figure out what times x gives you x squared. That's x, and then you get x squared. when you subtract it, that cancels out, and you're just going to bring down the negative 2x and do it again. So what times x is negative 2x? Negative 2. And I get negative 2x minus 8. These change, and you just keep the minus 8. When you bring down the minus 8, it's going to end up being a plus 8, but it really doesn't matter. Actually, we don't even need to do that. We can just bring down the minus 8 and not worry about it. So I'm going to end up with a remainder, but honestly, the remainder doesn't matter because I'm just graphing this anyway. So start at negative 2 and go up 1 over 1, and you have this line. That is your slant asymptote. Now, the cool thing about slant asymptote graphs is they're usually pretty self-explanatory. I know that I cannot cross this vertical asymptote because that means I divide by 0, and I know my end behavior looks like it's got to follow along the slant asymptote, so it's going to look something like this. Now, you're going to have a graphing calculator on this test, so if you're in any doubt as to a feature of this graph, just graph it on the calculator and see what it looks like. And that's what you should do for the last one as well. Okay, we can find that the x-intercepts, if I factor the numerator, are at 0 and negative 1. I can find those pretty easily. I can find that the denominator equals 0 at plus or minus 2, so those are vertical asymptotes at plus or minus 2. But as far as the actual features of the graph are concerned, you have a graphing calculator here, so what I would encourage you to do is graph it on your calculator and say, look, it's going to hug along that asymptote, it's going to do one of these deals. And then over here, if you look at the graph, it's just going to do one of these. And for most of our purposes, a sketch here is sufficient, and that's all we need. I could get the slant asymptote, I suppose, so let me get the slant asymptote. It's going to be x squared minus 4. So what do I multiply x by to get x cubed? X, and you got to distribute. So x cubed minus 4x, and then you flip the signs. So that's 5x squared. So then I can multiply by 5. And again, the remainder stuff doesn't matter. So x plus 5, 1, 2, 3, 4, 5, up 1 over 1. So I can be a little more specific here when I have my slant asymptote. I did pretty well on the bottom left, but the top one is going to actually be up here. Well, you saw it's like this. If you graph it on the calculator, you can see a little better. Okay, so for this one, when you see that you have two vertical asymptotes, you're probably just going to want to graph it on the calculator and see how it looks, and it's going to look something like that. So that's it for our rationals.